The PhET bending light simulation is really useful for explaining the refraction of light using wavefronts. Let's first of all consider the scenario where the light is going in along the normal, or the wavefronts are parallel to the boundary. After turning the light on, we want to adjust the refractive index to be about 1.5 for glass, make it so the ray is going in along the normal, and choose to have wave view. Then we can zoom in on the boundary and we can clearly see that the whole of each wavefront enters the glass at the same time, which means the whole of the wavefront slows down at the same time, which means it doesn't change direction. But the wavefront behind, which is still in the air, is going faster and so is catching up, and that means that the wavelength decreases. I like to use the analogy of cars driving along a road which reach a flooded section and they slow down when they get to the flooded section, so the car behind, which is still on the tarmac, starts to catch up, and that means that the cars get closer together, which is like the wavelength decreasing. Now let's consider at an angle to the boundary. So once again we want to turn on the light, adjust the refractive index to be about 1.5, and then increase to quite a large angle of incidence and change to wavefront. Zooming in, we can clearly see what's happening. The edge of the wavefront, which enters the glass first, slows down, whilst the other edge of the wavefront, which is not in the glass, keeps moving at a faster speed. And that leads to it getting ahead and causing the change in direction.